guys, again, welcome to Math with Teens. Don't forget to like, subscribe, and share our topic for today. Okay guys, our topic for today is all about variation. Under the variation, we have illustrating situations involving variations and translating relationship between two quantities into variation statement. So the word variation, if one of the quantities increases or decreases, the other quantity is also increases or decreases in a definite way. So we have different variations. First, we have direct variation. Second, inverse variation. Third, joint variation. And fourth, combined variation. The first variation is called direct variation. There is a direct variation whenever a situation produces pairs of numbers in which the ratio is constant. The statements we have first, y varies directly as x. The second one, y is directly proportional to x. And y is proportional to x. So these statements we use for the direct variation. In symbols, y is equals kx or y over x is equal to k, where k is constant of variation. Okay, so let us have the examples in a statement. We have to translate this in the equation of variation. First example, P varies directly as Q. The equation of variation is P is equal to KQ. P varies directly as Q, where K is the constants of variation. The second one, the cost C of meat varies directly as the number N of kilograms bought. How can we translate this in the equation of variation? So we have C is equal to K N. The third one, the weight W of an athlete is directly proportional to his height. So we can translate this into W is equal to KH. Yes, that is the examples of direct variation. Okay, another example in direct variation is in table. Look at this table. The first column we have time in hours, and the second row is distance in kilometer. So in time in hours, so we have 1, 2, 3, 4, 5. In 1 hour, the distance is 80 kilometers. So we have 2 hours, we have 160 kilometers. 3 hours is 240 kilometers and 4 hours is 320 kilometers. So what will be the distance in kilometer when we have in 5 hours? Meaning if you travel in 1 hour, you traveled as 80 kilometers. So we need to get the constants of variation first. How do we get the constant? So we need to get distance over the time. Distance in the numerator and the time is the denominator. Remember, distance is proportional to time. So we have 80 over 1. When we get 80 over 1 is equal to 80. 160 over 2 is equal to 80 also. 240 divided by 3 is also 80. And 320 is divided by 4 is also 80. So all of this, the constants of this 4 is 80. The same as 80. That we call the constants of variation. Ito yung hindi nababago. So, just like I said, distance is equal or varies directly as the time. Or distance is directly proportional to his time. So when we have, or if we have a constant of variation, let us get the equation of variation. So our equation of variation is d, the distance, is equal to 80. 80 comes from the constants of variation. So 80 t. That is the equation of variation. Then, if we get the last or the missing here, you need to substitute the value of t. Our t is 5. So 80, our constant, and t is 5. So 80 times 5 is 400. Meaning, if you travel in 5 hours, you have 400 kilometers. So that will be the direct variation in terms of table. Okay, another example in direct variation. In table again. Okay. So we have x and y. Y is directly proportional to x. Always remember that our denominator is x and our numerator is y. So y is directly proportional to x. So in x we have 16, 20, 24, 28. Always remember that they have the same difference. The difference of this, we just add 4. 16 become 20, so you just add 4. 20 become 24, add 4, and 24 become 28, so just add 4. How about in y? 12, 15, 18. So 12 become 15, so you just add 3, so it become 15. 15 become 18, so you just add 3 also. And 15 become what? So you just add 3. So meaning, our last or the missing part here is 21. So how do we get 21? So I said that y is directly proportional to x. So y over x. Let us get the constant of variation. So 12 over 16, 15 over 20, 18 over 24 is equal to blank over 28. So when we get the lowest term of this, all of these have 3/4, 3/4, 3/4. Our constants of variation is 3/4. How do we get the last term? So y is equal to kx, or y varies directly as x. So what will be the equation of variation? Your constant is 3/4. You have to substitute. So y is equal to 3/4 x. That is the equation of variation. To get the missing part here, so we have y is equal to 3/4. Your x is 28. So multiply, or you can cancel 4 and 28. So 28 divided by 4 is 7. Then 3 times 7 is 21. So that our last or missing term or missing number here is 21. Okay, now in the variation, we have an example in graph. So in our graph, we have x-axis, so we have time in hour, and y-axis, we have distance in kilometer. You have noticed in our plotting of points, so we have 1, then 80, 2 in 160, 3 in 240, and 4 in 320. So, for this graph, you notice that our graph is a straight line. So, meaning, if you have a direct variation, our graph is a straight line. So, what will be the constant of variation? Ano ba yung nadadagdag? So, again, so it additional by 80. So, 80 is the constant of variation. So what will be the equation of variation? So d bar is directly as t. Substitute the constant. We have d is equal to ATT. So that will be the equation of variation. Okay, our second variation is inverse variation. Inverse variation occurs whenever a situation produces pairs of numbers whose product is constant. For two quantities x and y, an increase in x causes a decrease in y, or vice versa. We can say that y varies inversely as x, or y is equal to k over x. Y is equal to k over x. Okay, our example in a statement in inverse variation, number 1, y varies inversely as x. How can we write in equation of variation? So we write this as y is equal to k over x. When we say inverse, we have over. Y is equal to k over x. The second one, the volume V of a gas at constant temperature varies inversely as the pressure P. How can we write that? So we have V is equal to K over P. Inversely. So over P. So that is the example in a statement. Example in table of values. So the first, distance in meter. So, in distance in meter in plants in a row, kapag magtatanim tayo ng halaman, so we have the distance in meter. So, we have 6 meters, 9 meters, 12 meters, 15 meters. So, you add 3 in preceding number. Then, plant in a row. So, nagpa-plant in a row tayo. So, we have 1 half, 1/3, 1/4, and what will be the last one? So, how do we get the last one? So, in example in tables, when we have a table, you just multiply only the distance in meter to plants in a row. So, how? 6 times 1 half is 3. Is that correct? 1 half of 6 is 3. The second one, PD is equal to 9 times 1/3 is also 3. 12 times 1/4 is also 3. And then, PD, 15 times 1/5 is equal to 3. How can we get 1/5? So, ang 1/5, so 3, so this 3 is the constant of variation. So, how can we get the equation of variation? So, we have P is equal to K over D. P stands for plants, and D stands for distance. So, the equation of variation is P is equal to 3 over D. 3 is the constant of variation. We need to substitute, so we have the equation of variation. So, P is equal to 3 over 15. P, so we don't have P here. So, we have 3 is the constant over 15 in our distance in meter. So, that P is equal to 1/5. So, meaning 15 times 1/5 is equal to 3. And that will be the last or the missing number in our table of values. Okay, that is one. Okay, let's have example in graph. In our graph, we have distance in meter at the x-axis and number of plants in a row in our y-axis. So, look at the graph now. So, the ordered pair of 1/5, then 15. So, this is 1/5, then 15. 1/4, 12. 1/3, 9. And 1/2, 6. How can you notice in our graph? In our graph, this is not a straight line, nor a parabola, but this is a half of two-part curve known as the hyperbola. This is the half of the hyperbola. So that will be the graph of inverse variation. So the constant of variation is in this graph is 3. So because the 1/5 of 15 is 3, 1/4 of 12 is also 3, 1/3 of 9 is 3, and 1/2 of 6 is 3. Our constants of variation is 3. So P is equal to K over D. And our equation of variation is P is equal to 3 over D. Okay, situational. Tell whether the situation is direct variation or inverse variation. Number 1, the number of hours to finish a job to the number of men working. So what kind of variation is this? Direct or inverse? The number of hours to finish a job to the number of men working. So, kapag marami bang nagtatrabaho, humahaba ba oras ng trabaho nila? No, yes. So, umiikli yung oras ng trabaho kapag dumadami yung nagtatrabaho. So, meaning, this is inverse variation. Next, the area of a wall to the amount of paint used to cover it. So, habang ba dumadami yung area ng wall, so, yung amount ng paint is dumadami din daw ba? Yes, habang lumalaki yung pipinturahan nyo, dumadami yung gagamiting pintura. So, that will be the direct variation. Correct. Number 3, the age of a used car to its resale value. Okay, binili mo yung car ngayon ng mahal. After 10 years, magkano na lang yung car mo? So, habang tumatagal, yung car mo is bumababa ang value. So, that is inverse variation. Number of persons sharing a pie to the size of the slices of the pie. So, you have a one whole pizza pie only for you. But, when you share your pizza pie in your sister or brother, so, yung share of pie mo, sa sarili mo, mababawasan. So, meaning you have inverse variation. And last one, the amount of money raised in a concert to the number of tickets sold. Of course, kapag marami kang nabenta, maraming ticket ang nabenta, marami kang yung nabentahan, yung money, the amount. So, meaning we have direct variation. Okay? So, do you know now how to differentiate the inverse and direct variation? Okay, now, joint. This is the third variation. Joint variation, the statement A varies jointly as B and C means A is equal to K, B, C. Or, when we get the constant of variation, K is equal to A over BC, where K is the constant of variation. Example in statement. The weight W of a circular disc varies jointly as the square of its radius and its thickness. How can we write that in equation? So the equation, the weight is equal to constant, don't forget the K. This varies jointly as the square of its radius. Square, meaning may squared ka doon. Square of its radius and its thickness h. So this is joint because nag-joint yung dalawang variable natin. So W is equal to KR squared H. The second example, the pressure P of a gas varies jointly as its density, D, and its absolute temperature, T. How can we write that? So we have P is equal to K dt. This is P equals the constant of D is the density and T is the temperature. So that is joint variation. Okay, our last is the combined variation. When we say combine, so we have to mix the all kind of variation, the joint, the inverse, and the direct variation. So that we call combined variation. The statement Z varies directly as X and inversely as y. Means z is equal to kx over y, or k, the constant, is z y over x, where k is the constants of variation. So example and statement. T varies directly as A and inversely as B. How can we write in equation? So T is equal to direct as A, so KA, and inversely as B, so over B. T is equal to KA over B. Okay. W varies jointly as C and the square of A and inversely as B. So how can we write that? So W varies jointly as, so C and the square of A, don't forget the K. So KCA squared and inversely as B. So W is equal to K C A squared over B. That we call the combined variation. Okay guys, that's all for today. It's only for translating into equation of variation. So again, so what are the four different variations? So we have direct, inverse, joint, and the last is combined variation. Okay guys, hope you are learned for our topic for today. Thank you for watching and God bless.